Hi, I'm Adam. Welcome back to GodotGameLab. In this video, we'll create the bread and butter of this project, the card dragging mechanic. In Slay Spire, we have two kinds of cards regarding this, single targeted and non-single targeted. Let's start with the easier one. If I start dragging the defend card and release it somewhere above the hand, the card gets played. Another way to do this is to left click the defend card once, start moving the mouse without holding the left mouse button, and click again. Also, there are two ways to cancel the movement. You can either right click or finish the card dragging below the play area. So let's see how this looks like in our game. You can see that we have this big card drop area on the top, and we have 3 cards in their base state in our hand. So if I hover over a card and left click once, it goes to this dragging state, and I can drag the card over the card drop area, and if I click again with the left mouse button, it gets released, and we have a debug message saying play the card for target's card drop area. Perfect. Now if we drag another one and we release it under the card drop area, it snaps back to the hand of the player. And also if I start dragging this card, drag it over the card drop area and right click, it snaps back to the hand of the player too. So this works exactly just like we saw in the video. Let's get started. So let's open up the project and start creating the card dragging mechanic. For the cards themselves, we'll use a combination of control nodes to display them and an area 2D to handle the card drop area logic. So let's start by creating a new scene. Click on this plus sign to add a new scene. And this time we'll start with a user interface node as a root node, a control node. Click on it and click on the control to rename this to CardUI. We want to add 2 child nodes to this. So click on the plus sign or press Ctrl A. And first let's add a color rect. This will be a temporary color we use, so we can differentiate between the different states visually for debugging purposes. Add this color rect, click on this and rename this to color. And select the CardUI, the root node again. Click on the plus sign again or press Ctrl A. And add a label node too. Click on the label node and rename this to state. Now let's zoom in to see what's going on a bit better. And for the card UI, let's set a size, a proper size for this. So go to layout, transform, and set the size to something like 25 by 30. It already looks much better, much like a card. So let's make sure that the color is inheriting this size. So let's go to the color, select this node, and under anchor presets, select full rect. And while we're here, we can change this color to something more pleasant, like a dark green maybe. So let's select a dark green color, something like this. And for the state, just write state for the text property of the label. And make sure it's aligned to the center on the horizontal and the vertical axis as well. And also make sure that it's inheriting the size from the parent node. So again, click on anchor preset and set full rect. You can see that the text is much bigger than the card itself. And this is what we have to address next. Okay, so for the label, we could do something like adding a new label settings, resource, or go to theme overrides, font sizes, and change the font size here. But we don't want to do this one by one for every single text we display in this game. It's much easier to rely on themes for this. So let's create a new theme. Select in the file system doc, select the root folder, right click, select create new resource, and search for theme. Add the new theme and call this something like main theme. Click on save. And you can see we have this theme panel at the bottom of our screen, and it's full of settings and previews and all that stuff, but we don't really need those yet. Because on the right side in the inspector doc, we can see the properties for the theme, and we have default font and default font size. Perfect. So let's expand the art folder and search for the Pixel RPG font. and drag and drop this to the default font. You can already see that all the previews have changed, but we need a smaller font size than this because our resolution is really small. So in the default font size property, let's change this to something like 6. You can see it's much smaller. We can close this theme dock or window by clicking on the theme again. And you can see that nothing has changed with the CardUI scene. Why? Well, because we have to assign this theme to the control node. So if we select the CardUI, the root node, and expand theme, we have this property for the theme. And we could just drag and drop the theme resource from the left side to the right side like we did before. But sometimes it's just easier to click on this drop-down menu, choose quick load, and you can see we already have the match offered for us. Click on open and boom, you can already see that the font is now fitting properly to the card. So let's save this scene because it's still unsaved, hitting Ctrl S. Go to scenes, create a new folder. Let's call this card UI. And CardUI.tscn is perfect. Don't forget, we also need to add an area 2D to be able to detect if we're over the CardDropArea or not. So make sure that the root node, the CardUI node, is selected. Click on the plus sign or press Ctrl A and search for area 2D. Click on this and rename this to something like drop point detector. And let's configure this area 2D. We have two properties on the top, monitoring and monitorable. So for this, we need monitoring to be enabled because we want to detect if we're over the CardDropArea or not. The CardUI themselves will be the ones handling this. So monitorable can be turned off in this case. And also under collision, we can set up the layers and the masks. So being on layer 1 is all right, but we can rename this to something more meaningful from layer 1. So right click on this, rename layer, and we call this layer card target selector. And we don't want to collide with other card target selectors. So put the mask on layer 2 and rename this layer to something like CardDropArea. We still have this yellow warning sign because we haven't added any collision shapes to this area 2D. So let's click on the plus sign and search for collision shape 2D. And for the shape, click on this drop-down menu and add a new rectangle shape 2D. Press W or click this icon to enter move mode. And if we go back to select mode or press Q, we can drag the handles to make sure that the collision shape covers the card completely. That's all the setup we need for now, so let's save the scene by pressing Ctrl S. Okay, so now we can add some stuff to the battle scene as well. Switch over on the top. First of all, let's zoom out to see what's going on better. And select the battle node, the root node, and click on the plus sign or press Ctrl A. And let's add an area 2D for the CardDropArea. And while we're here, we can rename this to CardDropArea as well. And under collision, we need to change it to layer 2 because this is a CardDropArea. But for the mask, layer 1 is fine because it targets the card target selector layer. Also, we have this yellow warning sign again because we haven't added a collision shape yet. So let's add a new node, this time a collision shape 2D. And under shape, we can add a new rectangle shape 2D. So we could start dragging the handles to make sure it covers the portion of the screen or the game screen we want, but we can be more precise if we want to. So if we click on this rectangle shape 2D resource, we can change the size to fit the whole width of the screen, so 256. And for the height, we can do something like 100 pixels, maybe like 2/3. And again, we could use the move tool to try to position it to cover the whole screen. But we can also just click under transform and calculate this position because we need to offset it by half of its width and half of its height. So we can calculate this by writing 256 divided by 2. And also we could write 100 divided by 2, but that's really easy to calculate that it's 50. So you can see that it fits the whole screen, or the whole width of the screen rather. That looks perfect for the CardDropArea, so let's save the scene. Now we can move on to the UI. So select the battle scene again, click on the plus sign, and this time we'll add a new canvas layer node to make sure that the UI is on a separate layer. Click on this and rename this to Battle UI. And under layer, make sure that it's set to layer 1, so it will be rendered on top of the game itself. And add a new child to this. For the cards, we could do something like a 3D fanning, which you can see in Slay the Spire. If you're interested in this, I'll link a really great tutorial video downstairs, but for the sake of simplicity, we'll just use an HBox container. So search for HBox container. Click on this and rename this to hand. And we need to add a couple of cards to see how it looks like. So with this instantiate child scene button or Ctrl-Shift-A, we can add the card UI. And also by pressing Ctrl-D or right-click and duplicate, we can add like 3 cards. And you can already see that something's really wrong here because we can't really see the text and the color rectangle either. That's because the HBox container is handling the size of its children. So if we want to make sure that all the cards are at least 25 by 30 pixels, we need to go back to the card UI scene. And on the card UI, we already set up the size, but it's not enough for using containers. We need to set the minimum size too. So let's modify this to 25 by 30 as well. And if we save this scene and go back to the battle scene, you can already see that it looks much better. But the hand itself is not really good at the top left corner of the screen. So let's change the anchor preset first. So let's make sure that this is a center bottom. And we also want to change in the layout and transform, we want to change the size to something like 150 by 30. And you can see that when we change the size, the position goes off. So if we go back to anchor preset and select center bottom again, it will recalculate the position. Now it looks much better. So with the hand ready, let's save the scene. And we can start creating the logic for dragging and handling the cards. But before we jump into coding, let me explain you how state machines work. So what are state machines? Imagine a simple elevator which can only go up and down one story. What kind of different states the elevator can be in? Let's call the first one idle if it's not moving and it is waiting for input. From idle, we can go into 2 states, going up and going down. From both of those states, we can go into one state and one state only, the stopped state. And finally, from the stopped state, we can transition back into the idle state. Keep in mind that for most transitions, we have a condition which needs to be met. To go from idle to either going state, the corresponding button needs to be pressed. To go from either going state to stopped, the elevator needs to arrive at its destination. So state machines have a finite number of states, and only one state can be active at a given time. On top of that, each state does one job, and that one job only. And the last one is really important, all states can transition into other states. So how does that work in our game? If we take a look at the most basic form of the CardUI state machine, we'll have a starting state, which we can call the base state. From the base state, we can go into the clicked state. From the clicked, we can go into dragging. And from the dragging, we can either go to the released state or back to the base state. And last but not least, from the release state, we can go back to the base state. Okay, now let's think about the conditions for a second. From the base state to go to the click state, we need to press the left mouse button on the card. From the click state to go into the dragging state, we need to detect mouse motion. From the dragging state to go to the release state, we either need the left mouse button to be pressed again or released if we were dragging the card. And from the dragging to go back to the base state means cancelling out the dragging mechanic, so we need to press the right mouse button. And from the release state to go back to the base state, we need to detect if the card is outside the drop area, which means that we let go or release the card below the drop area, so we need to cancel playing the card. And for this video, that's all there is to it. So finally we can do some coding, right? So let's select the CardUI node first and attach a small script to it. So click on attach script. CardUI.gd is perfectly fine. Click on create. The first thing we do is we assign a class name to this CardUI script, so it's a recognizable static type throughout the project. Then we define a signal for reparent requested, because when we start dragging the card, we need to reparent it from the HBox container, because otherwise it would be restricted within its bounding box. And finally, we reference two onReady variables, namely the color rect and the state label. And that's it for the CardUI script, at least for now. Let's save this script by hitting Ctrl S. Next up, we create the base CardState script, which all the other specific states will inherit from. So this will be just a script on its own. So if we go to the file system doc, right click on CardUI, and first of all create a new folder. Let's call this CardStates. Right click the CardStates folder and create a new script. And let's rename this to CardState. Hit create, expand the folder, and double click on CardState.gd to edit it. This script isn't too complicated either. First of all, let's assign a class name, so again, it can be referenced as a static type throughout the project. Then we define an enum, which will hold all the states the cards can be in, including the aiming state, which we'll only cover in a later video. Then we define a signal for transition requested with two parameters, the state we transition from and the state we transition to. Then we provide an export variable, so we can assign states themselves to the nodes in the editor. And also we'll have a reference to the CardUI node, so we can do stuff like moving or changing the color for the color rect or updating the label and all that kind of stuff inside the state scripts. Then we have two functions, enter and exit. Both of them will be called either when entering a new state or when exiting one. Then we have two other callback functions the state can use, the input events and the GUI input events, with the corresponding input event passed on as a parameter. And last but not least, we have two other callback functions, the mouse entered and the mouse exited signals. And really that's all we need for the base CardState script. So let's save this by pressing Ctrl S. With this out of the way, we can finally create the CardStateMachine itself. So let's go back to the 2D view, select the CardUI root node, and add a basic node as a child to it. Double click and rename this to CardStateMachine, and attach a new script to it. We call this CardStateMachine, but make sure it's with Pascal case because that's the convention for Godot. Now let's tackle this script. We start with the usual by defining a class name so we can reference the CardStateMachine anywhere else in the code. Then we have an export variable for the starting state or the initial state of the state machine, which will be the base state by the way. Then we have two variables, one for storing the current state we're in, and a dictionary for storing all the available states in the state machine. Then we have an init function, which we'll call from the CardUI. First, we iterate through all the children of the state machine. We check if the current child is a card state or not. If it is, we add it to the dictionary of all the states we have, and connect the transition requested signal to our own function where we'll handle the transition. And also, we pass the CardUI reference to the state itself. Then, if we do have an initial state, we enter that state and set the current state to this starting or initial state. Then we have two callback functions for the input and GUI input events. We check if we have a current state or not, and if we have an active current state, we can call that state's corresponding callback function. We do the same with the onMouse entered and onMouse exited callbacks. And finally, we tackle the transition from one state to another. The first thing we need to check if the from state and the current state is equal or not. Because if the two states are mismatching, then something really messed up happened and we need to immediately return from this function. After that, we store a reference to the new state from our dictionary of states. If for some reason we don't have these states in our dictionary, then we try to transition into a non-existing state, so we return from the function again. But if the new state exists, then first of all we need to exit the current state if we were in a state previously. Then finally we can enter the new state and set the current state to this new state. And that's all there is to it for the CardStateMachine code, so we can save this by pressing Ctrl S. Now we can add all the different states we have. So let's go back to 2D mode. Select the CardStateMachine and add a new node as a child. Press Ctrl D 3 times to duplicate this and rename the nodes to card base state, card clicked state, card dragging state, and card released state. Let's add all the scripts we need to these states too. So click on the attached script for the first one and make sure that the folder will be the card states inside the CardUI so we can keep things organized. And also make sure that it's in Pascal case to keep things consistent. So let's call this card base state. And also one thing we need to make sure of is that it inherits not from the node class, but from the card state class we created earlier. Let's click on create. We'll edit this later, but let's add all the scripts to all the 4 states we have. Phew, okay, but let's not forget to go back to 2D mode. And let's not forget to configure those. Because if I click on it, you can see that I need to select which state this node represents. So for the base, that's perfect. But for the clicked state, it should be clicked. The dragging state should be the dragging. And the release state should be the released. And for the CardStateMachine, the root node, we need to assign an initial state. So if we click on assign, you can see that all the card states are highlighted from the node hierarchy, and we can select the base state as our initial state. Let's not forget to save the scene, press Ctrl S. Now let's implement the base state. What do we need to do when we enter this state? Well, first of all, because this is the initial state, we need to check if the CardUI node is ready in the scene tree or not. Because if it's not, we need to wait for the CardUI to be ready. Why? Well, because if you take a look at the node hierarchy, you can see that the base state is way below the CardUI. And the way Godot works is the children get ready first, and the parent can only be ready when all of its children are already ready. So this is why we need to wait for it, because in theory, we could enter the base state earlier than the CardUI is ready. I hope that makes sense. Then we do a bunch of stuff. First of all, we request a reparenting for the CardUI if we enter the base state, because if you remember the state machine we planned for this CardUI, we can enter the base state from the dragging state if we cancel out the movement. And if we do cancel out, we need to snap it back to the HBox container. Then we change the color and the text for debugging purposes, and we also reset the pivot offset of the card. The pivot offset will be used when we drag the card. So we don't want the top left of the card to snap to the mouse cursor when we drag it, but rather the point where we clicked on the card. And for this, we need to set the pivot offset. But if we enter the base state, we can reset it to 0 vector. Then we need to handle the GUI input event, because if you remember, we can only transition to the click state from this when we press the left mouse button in the base state. So when we do, we calculate the pivot offset, so we can drag the card from that position, and also emit a transition requested signal to the state machine to transition from this state to the clicked state. Speaking of the click state, let's implement that one next. To quickly open the script, press Ctrl-Alt-O and search for click state. And first of all, let's get rid of all the auto-generated code. Now let's see what this state will look like. Actually, it's one of the easier ones. So first of all, we need to make sure to handle entering the state. What do we need to do here? First of all, let's change the color and the text to something different so we can debug and see if the state transition is working correctly or not. Another thing we need to do is to enable the monitoring on the drop point detector of the CardUI. Why here? Well, if you think about it, when we really click on a card, that's when we start interacting with it. So when we start interacting with the card, we need to make sure that the drop point detector is monitoring so we can check for collisions with the CardDropArea. Then we also need to handle one thing, the onInput event specifically, because if the event is an input event mouse motion, just like we saw the condition on the state machine chart, then we can request a transition from this clicked state to the dragging state. And that's all we need for the click state really. Let's save this with Ctrl-S. So now we can move on to the dragging state. Again, hit Ctrl-Alt-O, search for dragging state, open the script up and delete all the auto-generated code. So what's up with the card dragging state? Well, let's start by handling the entering part. So what do we need to do when we enter to the dragging state? Well, you can imagine that this is where we drag around the card the whole screen freely. And we need to do the reparenting stuff. So how do we do that? If we go back to the battle scene and go to 2D view, you can see that the card UI is under the hand. And we have to break free from the burden of being under a container because it restricts the position of this control node. So we could do something like getParent.getParent to arrive at the battle UI, but this is generally speaking a very poor solution and a bad practice. Here's why. First of all, what happens if we move around? So we have a UI designer, or we as the UI designers decide that, okay, this is not the perfect layout for this, and we move around. There's no guarantee that this structure will always remain the same. And on top of that, with that solution, we couldn't really test the card UI in any different environment because we need the card UI to be at least 2 levels below a scene for it to work. So there's a million other ways we could do this. I'll go with probably one of the easiest solutions, which is to select this Battle UI canvas layer node and go to the node dock and select groups instead of signals. Click on this text box and let's add this to UI_layer group. Click on add and you can see that this little icon appears next to the node, and if we hover over it, we can read that this node is in this group UI layer. So this will be quite a small group because that's the only node we add to this. But now if we go back to the script tab, we can do something like get_first_node in group UI layer. And we can store that node in a variable just to make sure we can check that there's such a node that exists. And if so, we can reparent the card UI to the UI layer node. Then we can change the color and the text for debugging purposes as per usual. And that's really all we need to do for entering this state. Another interesting point is transitioning either to the release state or back to the base state depending on what happened. So we use the onInput callback for this. So first of all, we set some flags. We set one flag for mouse motion, which is true if the input event which happened is an input event mouse motion. Then we set a flag called cancel, which is true only if we canceled out the dragging movement by pressing the right mouse button. And we also have a flag to set when we confirm the action, meaning that the card should go to the release state because we either press the left mouse button again or we release the left mouse button. And then we do some stuff. So if a mouse motion happens, then we need to update the global position of the card so it follows around the mouse cursor. So you can see that we also take the pivot offset into consideration. This is why we set it earlier. And then if we canceled the dragging mechanic. Then we request a transition from the dragging state back to the base state. Otherwise, if we confirm the dragging, meaning that we release the left mouse button or press it again, then first of all we set the input as handled, so we cannot accidentally pick up instantly a new card. And then we request a transition from the dragging state to the released state. And that's all for this script. So last but not least, we need to implement the released state. Let's start by making a first version of it. Press Ctrl-Alt-O, search for released, and delete the auto-generated code as per usual. And the first version will be super simple. We need to handle entering this released state, and all we need to do for now is to change the color and the state for debugging purposes, so the card gets stuck on this release state and turns into a purplish color and says released. For now, that will be perfect. Phew, okay, so that was a lot of coding for one setting, so maybe we should just check out what we have so far, right? Let's go back to the 2D view. And before running the project, I just wanted to mention that the hand looks a bit weird. I think it looks much cleaner if the cards are aligned to the center of the container. So real quick, just select the hand node and change the alignment from begin to center. And I think it looks much better already. So let's save the scene, hit play and see what happens. So we have all the cards here. It says state. And if I click and drag or press the left or the right mouse button, nothing really happens. Why? We set up the card UI, right? We have all the states, the corresponding enum values attached to them, but it's still not working. Why? Well, we need to hook up the state machine. If you remember, we have this init function where we set up the state machine and enter to the initial state. This is why it didn't update from state to base and the color wasn't changed either. So we need to call this init function. Where? Well, we'll do this in the card UI. Okay, so let's hook up the state machine in the card UI script. First of all, we need an already reference to the CardStateMachine itself. So for the IntelliSense to properly work, we need two things. We need to use the static type CardStateMachine for the variable, and also with the asCardStateMachine keyword, we need to cast this already variable to a CardStateMachine. Then in the CardUI's ready function, we call the CardStateMachine's init function, and passing on the CardUI itself as a parameter, so we can have the reference to the CardUI. Then we need 4 callback functions, the first two being the input and GUI input events. And the other 2 callback functions we need, the on-mouse entered and the on-mouse exited signals. That's all we need for the CardUI script, but these 3 callback functions need to be connected to the proper signals too. So let's go back to 2D view. Select the CardUI root node, and under the node panel, select signals, and let's find the signals we need. So first of all, we need the GUI input. Double click this, and on GUI input is a perfect name for us. So let's click connect. We already have this function defined, so it will just show us this green icon, which means that it's connected to the signal. And then if we click on the root node again, double click the mouse entered, click again, and connect the mouse exited signals as well. And now if we save the script and the scene, you can see that we have the 3 little green icons. And the ready and input callbacks are inherited from the node class, so we don't need to do anything with those. Okay, so now if we play the game, it should work, right? And you can instantly see the difference. So now it doesn't say text, the default label value, which we provided in the editor, but it goes to the base state. Okay, so if I click, something should happen, right? But if I click and drag, or just click either with the left or the right mouse buttons, still nothing happens. Why? Well, we have another interesting problem. Namely, that if we go to the base state, for example, you can see that we have this condition event.isActionPressed left mouse. And in the dragging state, we also have event that is action pressed right mouse. But we haven't defined any input actions yet for this project. So let's go to project settings, input map, click on this add new action text box, and type in left underscore mouse and right underscore mouse, and press enter or click this add button. And with those actions defined, we can click on the plus sign, and under mouse buttons, assign the left mouse button to the left one and the right mouse button to the right one. Okay, so with this setup, we can finally close this project settings. And now if we run the game, everything should work, right? Well, let's see. If I run the game, start clicking, still nothing. Dragging, nothing. Right clicking, nothing. Why on earth is it still not working? Well, in Godot with the control nodes, you really need to be mindful what you are doing. But fortunately, we have a really cool debugging feature in the editor. So if we go to debugger and MISC, you can see that we can track which control was clicked the last time. So if I go back to the game window, if I click on the background, it doesn't change. But if I click on the cards, you can see it changes. But we have some problem because I think I'm clicking on the card UI, but it says card UI/color. So this is why it's not working, because the color rectangle node eats up the input event, but all the code we hooked up so far relies on the card UI doing the input event. Fortunately for us, that's a really easy fix. If we go back to the 2D mode and select the card UI first, so let's check all the control nodes for this. Go to the inspector doc, and we can scroll down, and we have a section called mouse. And we have this property called filter. It's a really long description, but basically we have three options: stop, pass, or ignore. And stop means that this control node will register the input events and stop them from propagating further down the tree to other control nodes. And this is good because we want the card UI to stop the input event, because we want the card UI to be the one handling it. Now let's see for the color. So you can see that, okay, this is set to stop too. This can be good, right? Because it's further down the tree, so it will enjoy the priority of handling this event first. So let's set this to ignore instead. And just to be sure, check the label as well. But by default, in Godot, labels ignore mouse input events. So now if we save this scene and run the game, finally, I can click on the card, but I instantly get an error message. Why is that? Well, because in the card UI script, I forgot to reference the drop point detector variable, so we cannot set it from the state. But fortunately for us, that's an easy fix. If I drag the drop point detector from the scene tree and press Ctrl before releasing it, it will add this drop point detector as an on-ready variable. If I rerun the game, finally, after so many attempts, it should work. If I click on the card, it goes to the click state. And if I start dragging it, I can drag the card around. If I release it, it goes to the release state, and I can no longer do anything with it. Okay, so this works. What happens if I right-click to cancel out the movement? Well, it goes back to the base state, so I can pick it up again and drag it around. But it still doesn't snap back to the hand of the player. So probably that's the one thing we should address next. Okay, so how do we handle this snapping back or reparenting stuff? We already have a signal for this defined called reparent requested. And if you remember, in the base state, we emit this signal when we enter the state. So the signal is emitted, but there's no other node connected to it yet. So if we go back to the battle scene and go back to 2D mode, Who do you think should be responsible for the reparenting? I think it makes sense for the hand to do this because the hand is the original parent of all the cards before we start dragging them. So I think it makes sense to handle over this responsibility to the hand. So let's attach a script to the hand. And for this, we can select a different folder. Under scenes, let's create a new folder. Let's call this UI. And hand.gd is perfectly fine, but I switch it to lowercase to stick to the conventions. And let's delete the auto-generated code. As per usual, we'll start by assigning a class name to the hand script. And then in the ready callback, we iterate through all the children and assign a variable to the current children as a CardUI static type and connect the reparent requested signal to our own specified function, which will be a pretty simple one. All the thing we need to do is to reparent the child to ourselves. And if we save this script and run the game, we should be able to drag the card around. And when I hit the right click, start dragging and hitting the right click will snap it back to the hand of the player, just like we expected. But if I drag it around and release it, again, it works as expected because this means that the card should be played. But we still have a problem because remember we have this CardDropArea. You know what, let me show you. If under debug we turn on visible collision shapes and run the game, again, you can see that we have the CardDropArea over here. So if you remember from the Slay the Spire demo, if we drag the card around and release it here, it shouldn't be released, but instead this means that we cancelled playing the card too. Instead it gets released. So it should only go from the dragging state to the release state if we have the card hovering over the CardDropArea. We need to address this problem next. Fortunately for us, this will be relatively easy to do because we set up everything correctly. So first of all, let's go back to the CardUI scene and switch back to 2D view. Select the drop point detector area 2D. And under the Node tab, make sure that Signals is selected. And connect the area entered and area exited signals to the CardUI's script. So double click area entered, make sure CardUI is selected and click connect. And do the same for the area exited signal. The question is, what do we need to do when we hover over or exit the CardDropArea? First of all, we'll define a new variable, which is an array of nodes, which will hold all the current targets for the card. Then if we go down to our new functions, we need to do two things. When we enter an area, meaning that we hover over the CardDropArea, we'll check if the targets array has this area already or not. And if it hasn't, we append it to the current targets. And when we exit another area with the drop point detector, we erase that area from our current targets. And that's all there is to it regarding the CardUI script. But don't forget that we also need to change the release state, because currently we can transition back from the release state to the base state. So press Ctrl-Alt-O and search for released state. And let's change the script up a bit. So what do we need to do here? First of all, let's introduce a new member variable, a flag called played, which will keep track if we play the card or not. And when we enter this released state, we can confidently say when entering that we haven't played the card yet. Then we can check our newly defined targets array from the CardUI to see if it's empty or not. If it's not empty, that means we have a valid target, which in this case means that we hovered over the CardDropArea. And if so, we set the played flag to true and print out a debug message so we can see if it's working or not. Another thing we need to do is on the input callback, check if we play the card or not, because if we play the card and we receive any kind of input, we don't really care about it because we already played the card. But if we haven't played it yet and we receive an input, this means that we don't have a valid target, meaning we should instantly transition back to the base state. And you could ask, hey Adam, why don't we just go here and type something like else, meaning if it's empty, then we can transition back, blah, blah, blah. So here's the thing. when we are inside the enter function, it means that we are currently entering the state. And we can't transition from this state to another one if we haven't finished entering this state yet. Right? Because if we go back to the CardStateMachine, you can see that if we request a transition from one state to another, we should first of all, before entering the new state, we should exit the current state. Right? But how do we exit it if we haven't even entered it yet? Because entering the state means running this function all the way through. Right? Because you can see that first we enter a state and then we set the current state to the new state. So we couldn't really transition from here. This is why we check the input callback for this. This works perfectly fine. So with these modifications, if we save this script and run the game, now we should be able to still release the card over the CardDropArea. And you can see that our targets array is working properly because we see that we hovered over the CardDropArea. But if I start dragging the card under or below the CardDropArea and release it, it goes back to the base state immediately, just like we expect it to be. But if I hover over it and release it, it gets released. Perfect. So before wrapping up this video, I want to show you a hard to spot but rather annoying bug we have with the current code. So I go back to debug and turn off visible collision shapes so you can see what's going on better. And if we run the game again, everything looks fine, but we have a small little inconvenience. So if I hover over a card, click on it once with left mouse button, it works as expected, right? I can drag it around, click again to release it. But sometimes, did you see that? I clicked once with my mouse. And sometimes it picks up and starts dragging it, but sometimes it instantly snaps back to its place. Why is that? It's because sometimes it happens so fast that it registers it both as a left mouse button press and release really fast. So it just instantly snaps back to its place, and it's really annoying because if I click on a card, I expect it once, I expected it to start dragging. So how do we fix this? Let's open up the dragging state script. So Ctrl-Alt-O, search for dragging state. And you can see that the problem is this, that we release the left mouse button right after a couple milliseconds after pressing it, and it registers as both a start of the dragging in the click state and the release in the dragging state. So to counteract this, we could introduce some variables and make sure that we need some time elapsed in the dragging state before transitioning to another state. So we'll do exactly that. So knowing what the problem is, the fix itself is pretty straightforward. We'll introduce a constant called drag minimum threshold, which is given in seconds. You can play around with this value, but I found that 0.05 works pretty fine. And we'll also introduce a new flag called minimum drag time elapsed, which is by default false. And when we enter the function, we set the minimum drag time elapsed to false. And we'll also create a new scene tree timer with getTree.createTimer. And the timer will be drag minimum threshold long. And also you need to make sure to pass false as a second argument, because for create timer, by default, the timer will run when the scene tree is paused as well. By passing false as a second argument, we specify that the timer should be paused when the scene tree is paused too. And for the timeout signal of this timer, we connect an anonymous function where we change this flag to be true. So we have the information now in this variable, whether the minimum drag time elapsed or not. So all we need to do is down here, when we check for confirmation, which means releasing the left mouse or pressing it again, we also need to make sure that the minimum drag time elapsed and we confirm the action. And only then we can transition from the release state. And with these fixes, if I run the project again, I can no longer do this weird weird things I was able to do before. So if I click and drag really fast, it doesn't snap back on its own. Only if I release the mouse button. Okay, so with that fixed, I think that's it for this video. See you in the next one. Bye bye.